Welcome to Get Your FRQ On. This is from the 1999 Calculus AB exam. It is question 6 and it is calculator active. For the question stem for question 6, we are given a graph of a function, a line that is tangent to the function, a point P with coordinates w comma 1 over w squared. In fact, the function whose graph we are given is y equals 1 over x squared. A point Q whose coordinates are w comma 0, and K, which is essentially the x-intercept for the tangent line to this function at any point. All right, in the first part of the question, part A, we are asked to find the value of K when w is equal to 3. So again, remember, this is essentially finding the x-coordinate for the x-intercept of the tangent line. So in order to do this, we need to find the equation of the tangent line when w is equal to 3 and then determine its x-intercept. All right, so the value of K is essentially the x-intercept of the tangent line. All right, so we need to first find the equation of that tangent line at w equals 3 and then determine its x-intercept. Well, the function is y equals 1 over x squared. This is a function we should certainly be able to differentiate at this point. And when we do, we find that dy dx is negative 2 over x cubed. All right, when we evaluate this specifically at w equals 3, we get negative 2 over 3 cubed, which is negative 2 27ths. So the slope of the tangent line in question is negative 2 over 27. Right, now if w is equal to 3, that means the point on the curve is going to be 3 comma 1 over 3 squared, or 3 comma 1/9. And if we plug those values into the point slope form for this tangent line, we get y minus 1/9 is equal to negative 2 27ths x minus 3. And the x-intercept will occur whenever y is equal to 0. So if we substitute in x equals k and y equals 0 and solve, we will eventually get k equals 9/2. So for part A, the value of k when w is equal to 3 is 9/2. For part B, assuming that w is greater than 0, we are asked to find k in terms of w for any w. Well, basically the same idea will apply. Right? For any x equals w, and assuming w is greater than 0, dy dx is just going to be negative 2 over w cubed, just substituting w in for x. Right? So if the slope of that tangent line would be negative 2 over w cubed, we can write sort of an equation for that tangent line for any value of w, just not a whole lot of specifics. So that would be y minus 1 over w squared equals negative 2 over w cubed times k minus w. And again, to find the value of k, which is just the x-intercept, we're going to let y equal 0. And if we set y equal to 0 and simplify, we eventually find that k is going to be 3/2 of whatever w is, which checks with part A. In part A, w is 3, 3/2 of 3 is 9/2, and that is the solution we got for part A. For part C of this question, we are given that dw dt is equal to 7 and asked to determine what dk dt is when w is equal to 5. All right, we just found a formula for k in terms of w. K is 3/2 w. And we can use implicit differentiation to determine that dk dt, which would be 3/2 times dw dt. But dw dt for part C is 7, so 3/2 times 7 is just 21 over 2. Now notice that 21 over 2 is a constant. There's no k in there, or w, or t, or x, or y. There's nothing. It's just 21 over 2. So dk dt when w equals 5 doesn't really depend on w at all. It's just always going to be 21/2. For part D, if dw dt is equal to 7, what is the rate of change of the triangle PQR in the picture, and is that area increasing or decreasing? Well, to begin, we need to be able to find the formula of triangle PQR. Right? The dimensions of triangle PQR, the base is k minus w, right? It's the x-intercept minus the original value of x, which at this point is just w, and then the height is just the height of the function, which is 1 over w squared. Right? So those would be the dimensions of triangle PQR, and so using the formula for the area of a triangle, the area of triangle PQR is k minus w over 2w squared. Right? But since k is equal to 3/2 of w, the area is w over 2 divided by 2w squared, which simplifies into 1 over 4w. And then if we differentiate that, dA dt is negative 1 over 4w squared times dw dt. But dw dt is given as 7. All right, so dw dt equals 7 and w equals 5. dA dt specifically when w is equal to 5 is going to be negative 1 over 4 times 5 squared times 7, which is negative 7 over 100. Right, so that is the rate of change, but notice that it's negative. Negative 7 over 100 is less than 0. So at this particular point with these conditions, the area of triangle PQR is decreasing.